So this is based on compound generator. So it says long shunt DC compound generator delivers a load current of 50 ampere at 500 volt. So it delivers load current of 50 amperes at 500 volts. Armature series field and shunt resistances are armature series field and shunt resistances are 0.05, 0.03 and 250 ohm respectively. Calculate the generated EMF and the armature current. Allow 1 volt per brush for contact drop. So brush contact drop is 1 volt per brush. So this is the given problem data. So it's the case of a long shunt compound generator. So let us draw the equivalent circuit. So it's a long shunt. Okay. In case of long shunt, what happens is that the series field is connected first, followed by the shunt. And this is then connected to the load. Right. So they have told load current is 50 amperes. At 500 volts. So load voltage is 500 minus plus. The armature resistance is 0.05 ohm. Series field resistance is 0.03 ohm. And shunt field resistance is 250 ohm. 250. And you need to determine E, right? So you can apply KVL in the clockwise direction. So when you apply KVL, the generated voltage EG. Okay. So this is your EG. Upper side positive, lower side negative, and then comes IARA drop plus minus. So this is your armature current IA. Series field current ISC. Shunt field current ISH. Right. So you can write EG. So generated EMF EG is IA into RA and RSC are connected in series. So RA plus RSC plus the terminal voltage across the field winding. So voltage across field winding is nothing but voltage across the load. So that is VT. And you have been asked to consider the brush contact drop. Alright. So therefore, EG is equal to IA. Do we know IA? We don't know IA, that we are supposed to find out. Into RA is 0.05 plus RSC is 0.03 plus terminal voltage is 500 plus brush contact drop. So they have asked us to take 1 volt per brush, and we have pair of brushes, A and double A. So it is 2 into 1, that is 2. Okay. So let's find IA. Now, when you apply KCL, what you see is the incoming current is IA and the outgoing currents are ISH and IA. So incoming current IA is equal to the summation of outgoing currents ISH and IA, where IL is 50 amperes. They have given in the data, and ISH can be found using Ohm's law, right? Voltage by resistance. So voltage across shunt field winding is 500 divided by resistance is 250. So that is 2 amperes. So therefore, armature current IA is load current 50 plus field current 52 amperes. So IL is 50 and ISH is 2 amperes. Okay. So 52 amperes. So that implies it is 52 into 0.08 plus 500 plus 2. So EG is equal to, how much you get? EG is equal to 506.16. 506.16. So you have found generated EMF as well as the armature current. So that is your first problem. So if you look at the approach, it is similar to your shunt motor, correct? So that's the first problem for the day. Second one, let us consider. So the second problem for the day going to be from short shunt, right? So we have considered long shunt. Now let us consider short shunt. The sixth problem in generator is short shunt. Okay. So it says in a 110 volt short shunt compound generator, the resistance of the armature, shunt, and series windings are, so they have given the three resistances 0.06, shunt is 35 ohm, and series field is 0.04 ohm respectively. The load consists of 200 lamps. Load consists of 200 lamps, each rated 55 watt on 110 volts. Find the generated EMF and armature current. So same thing you are supposed to find. EG and IA needs to be found. Alright, so this is the given problem. So what we can do is we can quickly construct the equivalent circuit. Okay, so first let us construct equivalent circuit. So it's a short shunt compound generator. So accordingly, you have to draw this circuit. So in case of short shunt, what happens? The shunt field winding is placed before the series. So this is your armature resistance. And This is your shunt field followed by series field, and this is your load. So load is consisting of 200 lamps, each having a rating of 55 watt, 110 volts. So this is lamp 1, lamp 2, so on and so forth. First lamp, second lamp, and this is 200 lamp. So lamp rating is 55 watt, 110 volt. So you look at the voltage. So 110 volt is the voltage rating of the lamp. So what happens is that the 110 volts can be considered as the terminal voltage, plus and minus 110 volts. All right. And you can mention the resistances. This is RSC, RA, and this is RSH. Okay. So RA, RSC, RSH, everything is written here. I'm not going to substitute the values here. It becomes very cumbersome. Okay. So this is your generated EMF, EG minus plus, and this is your voltage drop, IAR plus and minus. All right. So this is ISC, the series current, and this is your load current IL. Okay. So first let us do the load current calculation, right? Solution. This itself is your load current. So load current IL is equal to ISC for a short shunt machine, right? Because the same series current will flow as the load current. And what is load current? Your load current IL is nothing but IL1 plus IL2 plus IL2, right? Because there are 200 lamps. So if you can calculate current flow through one lamp, you will be able to measure the total current flow through the load. So let's say this is IL1. So IL1 is equal to, okay, the power rating is known, 55 watt, and voltage rating is known, which is 110 volts. So basically we have P is equal to V into I. So I is equal to P divided by V. So IL1 is equal to 55 divided by 110. So that is 0.5. 0.5. Therefore, total load current IL is equal to, so one lamp draws 0.5 amperes. So 200 lamps draws how many amperes? So basically it's the addition, or you can say 200 into IL1. The total current is 200 into 0.5. So that is IL is equal to 100 amperes. All right, so that's how you calculate IL. Once IL is calculated, you can find out ISH. So ISH is VSH divided by RSH. So let us mark first VSH. Okay. So this is our VSH. Voltage across shunt field winding is VSH. So what is VSH? So to find VSH, you can apply, KVL in the second loop. I have done it in the theory. You can just, flip back the node pages to understand how to write an expression for VSH. Nevertheless, I'll do it here. So apply KVL in loop 2. So when you apply KVL in loop 2, VSH minus ISC RSC minus 110 volt, right? Or you can say that VSH is equal to IL into, because IL is equal to ISC, RSC, right? IL into RSC plus the terminal voltage VD divided by RSH, or ISH is equal to load current is 100 into RSC. What is RSC? RSC is 0.04 plus terminal voltage. How much do we have? The terminal voltage as 110 volt divided by RSH. What is the resistance of field? 25. So when you simplify this, you will get ISH. So ISH, you will get it as 4.56 ampere. So IL is known, ISH is known. So therefore, you can find IA. So IA, that is this current. So what is IA? IA is equal to ISH plus IA. So this is ISH. Right. So incoming current is IA and outgoing currents are ISH and ISC, which is nothing but IA. So ISH plus IL, or IA is equal to, what is ISH? 4.56. And what is IL? 100. So armature current IA, you will get it as 104.56 amperes. 104.56 amperes. So armature current is formed. Once armature current is formed, you can find out the induced EMF. So induced EMF EG is equal to that is summation of EMFs is equal to summation of potential drops, right? So summation of EMF EG and potential drops. So IA RA plus VSH, right? Voltage across that shunt field, and plus brush contact drop. Have they asked us to take it? I don't know. Okay, no brush contact drops. Cool. So no brush contact drops. So you can just assume it as 0. Or EG is equal to IARA plus VSH. We have already written an expression for VSH here. So what is it? IN into RSC plus VT. And that is equal to, can substitute the values 104.56 into RA 0.06 plus IL is 100 into RSC plus VT, which is 110 volts. So that will give you EG. So EG, you will get it as 120.27. 120.27. Okay, so that's the solution for this problem. It's a very important problem. Very important. So you see how easily you can solve just by applying the very conceptual knowledge of KVL and KCL. So any DC machine problems can be solved just by applying KVL and KCLs. All right. So that's the reason we stress on the fundamentals. So let me erase. All right. Let's consider the seventh problem. Right. A DC shunt generator supplies a load of 30 kilowatt. So it's a shunt generator, supplies a load of 30 kilowatt at 300 volts. At 300 volts through a pair of feeders. Through a pair of feeders. Feeders are nothing but wires, copper wires. Feeders are nothing but copper wires, power system terminology. Feeders, each having a resistance of 0.02 ohm. Of 0.02 ohm. Feeders having resistance of 0.02 ohm. So each feeder is having 0.02 ohms of resistance. RA is 0.1. RSH is 100 ohm. Find the terminal voltage. Find the terminal voltage. That is VT. And the induced EMF in the generator. Find the terminal voltage and the induced EMF in the generator. All right. So it's a shunt generator. So let me draw the circuit. This is also a very important problem. So first, let me draw the generator, and let me show you the feeder connection also. Okay. So shunt generator. This is RA. The shunt winding. RSH. Field current ISH. Armature current IA. Okay. So let me first write what do you mean by feeder. Feeder is nothing but copper wire. So feeder connects generator to the load. is nothing but a wire which connects your generator to the load. So as you can clearly observe that we need to have two wires, one for positive polarity and one for negative polarity. So this is your positive polarity wire and this is your negative polarity wire. All right. So basically, I can show feeder with the green wire, and each feeder is having a resistance of 0.02 ohms. So let us show the resistance of the feeder. Okay. 0.02 ohm, and this is also 0.02. And this is then gets connected to the load. Right. So load rating is 30 kilowatt at 300 volts. So this is then connected to a load. So load rating is 30 kilowatt at 300 volts. Now what has happened due to the presence of feeder resistance? Okay, this is your feeder. Due to the presence of feeder resistance, the 300 voltage which is present across the load will not be same that across the field winding, because there is some resistance between the shunt field winding and the load. So whenever there is resistance, there will be voltage drop. So we need to find the terminal voltage VT across the shunt field winding. You may have observed that in all the previous problems, the voltage across shunt field we used to take directly as the voltage across the load. But in this problem, this is a very special problem in which VT is not equal to the load voltage. Okay. If not equal to load voltage, what it should be, that we are supposed to find out. All right, fine. So first let us find out the load current, because I have the power description as well as voltage description. So first let us find out IL. So IL is equal to P by V, right? So P is 30 kilowatt and V is 300, right? So basically we get it as 100 amperes as your load current. Fine. Once you know the load current, you can find out VT, right? So to find out VT, probably you can apply KVL in loop 2. Okay. So to find VT, let me write. KVL in loop 2. So what is it? Minus to plus VT. Then plus to minus, because it's a drop, no? What is the current which is flowing through 0.02 ohm resistance? It is IL. So minus 0.02 into IL. Plus to minus, that is minus volt. 300. Then again, current flows like this, right? IL will flow like this. So plus to minus, again negative drop, 0.02 into IL. And do we have any brush contact drops? No. Brushes will not come into picture in loop 2. E is equal to 0. Or you can find out VT is equal to basically 0.02, 0.02 gets added. So it is 0.04 into IL. IL is 100 plus 300, right? So basically 304 volts you will get. 304 volts. So VT is 304 volts. Once VT is known, you can find out EG. So EG is equal to IARA drop plus the terminal voltage V. And there's no information of armature reaction drop and brush contact drop, so you can directly take it as 0. But we need to know what is IA. So IA is equal to ISH plus IN, where IN we have already found, but we need to find ISH. What is ISH? ISH is nothing but voltage divided by resistance. So VT by RSH. So VT is 304 divided by RSH is 100. Right. So that will give you ISH 3.04. So ISH is 3.04 amperes. Done? Now you have to just substitute, right? So IA is ISH plus IN, which is 100. So 103.04 amperes. So that is your IA. So 103.04 into resistance 0.1 plus 304. That will give you EG equal to 304 plus this 310, something like that. You should get it. 314.304. Your EG.